Yes, well, thank you very much. I'd like to begin by acknowledging my co-authors within SAMS and more broadly University of the Highlands and Islands, as well as most especially our colleagues from the University of Exeter, who are without whom this work could not be completed. What I will be talking to you about today is a summary of a piece of work that was commissioned by Scottish Natural Heritage to investigate the potential risk of entanglement, which we can define here as the process by which animals become restrained or otherwise captured in vertical structures, ropes, chains, etc. of anthropogenic origin that have been placed in the water column. And this is a significant conservation concern for many marine species around the world. Tens of thousands of animals become entangled, entrapped. The terminology is sometimes slightly confused or mangled and mixed up in the literature, but at the very least animals are restrained to the point where they either die or escape with injuries. And within the context of marine renewable energy, the question has been posed to what extent moorings associated with devices could potentially pose a similar sort of risk. So we were asked to investigate this in a bit more detail. For the focus of this presentation today, we will be looking at a range of different groups, not just marine mammals, but also we consider species such as turtles, large sharks, and other fish such as ocean sunfish. And it should be pointed out that many of these groups fall under certain legal requirements to investigate the risk to them at an individual level in some cases, as well as a population level. We initiated this process by undertaking a literature review of recorded cases of entanglement in the published literature, the grey literature, anecdotal reports, and it rapidly became apparent that the vast majority of entanglement cases involve fishing gear in one way, shape, or form, either actively fishing or gear that has been discarded. There is a small number of reports, I should say, that involve animals, particularly large whales, becoming entangled in ropes associated with aquaculture. Then there are reports from subsea cables. I'm not entirely sure why this is happening, but I do apologize. These are historical reports, particularly of deep diving animals becoming entangled in telecommunication cables. That problem seems to have now been largely resolved due to the cables being buried more often. But there are also a few reports, not many I stress, of animals, particularly large whales, becoming entangled in moorings and anchors, particularly associated with boats that anchor. And this is perhaps the closest analogy to an entanglement involving a marine renewable energy device. This particular example is a fin whale that became entangled in an anchor chain of a fishing boat and subsequently died of its entanglement. Here we are, here we see some of the chain, some of the cable wrapped around the animal. And so from this review process, it became apparent that the main group of concern might be baleen whales, particularly large baleen whales such as humpback and fin whale. There was, however, another concern that became apparent, and that was the potential for derelict fishing gear that was discarded or lost from fishing boats to become snagged on moorings in these highly energetic environments and subsequently start to act as ghost nets to continue to entangle or entrap a wide range of animals, not just these large ones, but also seabirds, for instance. Given the relative absence of large volumes of data, because so few devices are in the water at the moment, our colleagues at Exeter undertook a mooring modeling exercise to come up with a sort of a qualitative risk assessment process. So using the software package Orcaflex, they simulated a fairly simple floating structure, which is that red cylinder you see in several of these images, which was attached to the seabed by a 3-line mooring configured in a number of different ways. There were 6 configurations that were modeled in total, 4 catenary moorings on the top, with or without accessory buoys and consisting of a number of different components, and 2 taut mooring configurations, such as the ones at the bottom. And the behavior of these moorings was described, simulated across a range of different environmental conditions. And a number of these modeling results were used to characterize a number of different mooring features, such as the tension characteristics found in the mooring lines as the moored body moves laterally from left to right and back again. Swept volume, that is the 3-dimensional volume of the water column that is being impacted by the moving mooring under these conditions. And mooring curvature. The software allows you to establish the changes to the curvature in great detail, and so these parameters were considered to be quite important in assessing entanglement. It should come as no surprise that these different mooring configurations have fairly different responses in terms of these characteristics. On the top we see the tension in the different mooring lines. The curves are not exactly mirror image because of the fact that the movement in one direction involves tension on only one line, whereas the movement in the opposite direction involves tension on 2 lines. But I would like to point out that the taut mooring, for instance, those curves have a very different shape and orientation than the adjacent graph, which describes a catenary mooring containing chain and nylon. The swept volume graph here at the bottom, again, it shouldn't come as a great surprise that these moorings behave differently and impact different volumes of water as they move about under different conditions. Finally, the curvature graphs here, these represent box plots describing the angles at different points along the mooring. And again, it shouldn't come as a major surprise that a taut mooring displays far less curvature than a catenary one. We then proceeded to assign, more or less arbitrarily, and this is something that we can have a discussion about, a risk factor to each of these different categories. So in the top right, we have, it's slightly difficult to see, but we have the various tension graphs for all the moorings combined in one graph, overlaid by a risk matrix. So very broadly speaking, we decided that high tension in a mooring is a good thing, whereas low tension, very flexible mooring, that is considered a bad thing. So we gave it a higher risk score. Similarly, for the swept volume, if the mooring line does not impact a large volume, that is considered to be a good thing, whereas if it moves about a lot, that is considered a bad thing. And similarly for the curvature, the more the mooring is capable of curving, the worse it is. And similarly, we can assign risk factors to biological parameters, such as body size. The larger an animal is, in the case of large whales, for instance, the easier it would be for an animal to become entangled, or conversely, the harder it would be for a small animal to become entangled. Body flexibility, the more maneuverable an animal is, the easier it might be to avoid a mooring. The sensory system of an animal has a part to play as well. If an animal is capable of detecting a mooring at long ranges and thus avoid it, that is considered to be a good thing. And the feeding mode as well. If animals, such as large baleen whales, engulf large volumes of water, there is an increased risk of encountering a mooring inadvertently. And we can assign risk factors to those sorts of things as well. And if you combine these, you end up with what I stress is a relative risk assessment here, but it describes how different groups of animals might be put at risk by different kinds of moorings. And these are all, I stress, standardized mooring configurations that are widely used across the industry. And what comes out of here is, first of all, that baleen whales at the top are at greatest relative risk for the vast majority of these moorings, largely due to both their size and their feeding habits, I should say. And also that there is, in fact, a distinct difference between the risk posed by a number of these different kinds of moorings. For instance, a taut mooring represents a much lower risk than some of these other mooring configurations. So, to wrap this up, there are, unfortunately, in some ways, very limited data at the moment out there on entanglements that do not involve fisheries at this point. And largely this is due to the fact that so few devices have been put into the water at any sort of scale. Following this review, we feel that the mooring entanglement risk is likely to be relatively low for the most groups of marine megafauna, with the possible exception of baleen whales, particularly the larger species. The mooring design clearly influences the relative risk posed to some of these groups in terms of entanglement. This is an assessment process that we've developed here, can clearly be refined as more data become available. We did not apply any weighting factors, for instance. There are other parameters that could potentially be included, but we feel that this is a good place to begin. It is also important to point out that these parameters are regularly collected by the developers themselves in the process of their mooring design. So this was not meant to pose an undue burden on developers. This is information that they generate anyway. And we feel that it would be helpful if this information could be passed along to the regulator as part of an EIA-style process to inform them about the potential risk that individual mooring configurations might place on animals. We did not spend a huge amount of time looking at arrays because there is such variability in device configuration, array configuration, device density, and an important point to consider, the extent to which different devices use the same mooring, whether they share the same mooring, which will obviously impact the risk that that array might pose in terms of entanglement. And finally, I would like to put it to you that there is a need to investigate more broadly the extent to which derelict fishing gears become attached to these structures in the water column, and to what extent they actually pose an entanglement risk to marine megafauna in Scottish waters and elsewhere, in fact. So with that, I would like to end, and if you have any questions, please let me know. Thank you.
Thank you. We do have time for a question.
Yeah, in your initial literature search, did you find that any particular species was more associated with entanglement than another?
In terms of, in the fishing, since most of the records involve fishing gear, because fishing gear itself is a very varied category, it was very difficult to it would be very difficult to say. Different groups of animals are definitely associated with different kinds of fisheries. For instance, if you have fixed net fisheries or even creel fisheries, where you have lines running up to solitary buoys even, those sorts of lines will tend to entangle large whales, but also things like sea turtles. It's difficult to summarize that for the fishing industry because it is so diverse. And there are also, of course, significant local differences from area to area. But all of these species become entangled in these sorts of gears to a certain extent. What's that?
Yeah, I was just thinking the comparison between fishing gear entanglement and this intentional entanglement. Fishing gear would generally be clean in terms of the ropes would be not foul, whereas all these devices and all their moorings with all the biofoul engines will be potentially very effective fish tracking devices. So I think the situation is quite different comparing fisheries-based entanglement and the entanglement risk down deep, because there's going to be a very unique, different ecosystem based around these very heavily fouled moorings.
That's true. The risk that a mooring will pose in terms of entanglement is likely to change over time as the mooring becomes progressively more fouled. I would argue, though, that in some cases the ecosystem that you describe may actually attract some of these animals to the vicinity of the mooring, thereby potentially increasing entanglement. In the sense, not so much the mooring as the floating waved energy device itself, under which fish might aggregate, etc. But I agree, this is the closest analogy we have. to this potential problem.
Thank you very much, Steve.